the, oops, cancel. Under the describe the data or collect the data, so we all have to fill out that worksheet and send it in.
Oh,
I
okay.
thought only I had
Get
to.
to you.
I
Hold
think
on.
that's just me.
Let me double check that.
Did you ever hear back from him on your questions about?
Still, he just responded this morning, and I'm replying. I still need to reply. He was saying that because we said that he said the reason I marked you down on the sampling method was because you said simple random sample, but as the feedback said, his response was each bag should be considered a cluster in which you count all the colors. But we are doing that, and
Mm-hmm.
I thought I had written that in our study, so I'm just checking that. Including a little brand. Yes, I listed that. So he's just not reading carefully.
Okay.
Because I did say that each sample will be separated by color and counted and recorded in the table.
Mm-hmm.
Their quantities and individual distributions. So he just skipped over that. So I'll reply to that.
Okay.
Still. And then also I'm just double checking that submission. Hold on. Whether or not we just give it to Phil and that's what he uses to come up with his describe the data, or if we literally have to turn that in. Because I thought it said, yeah, we all have to turn in the collect the data form.
Okay.
And then, but we'll want to forward at the very least. We should forward what we come up with to collect the data. That would be helpful as Phil, you're writing up your summarizations and everything for the description.
Okay.
And then we'll definitely give you all of our data in the Excel file.
Okay.
You can look at that too.
Okay.
So by next, are we in week 10?
Yeah.
Okay,
Yeah.
so by this Saturday, we all have to submit that collect the data sheet.
Okay. Yeah,
then,
I can do that. I
and
can
then
get that done.
do the week after that, right?
And I'm trying to get, I'm going to need everything too for the PowerPoint. Yeah, I took some pictures of like the M&M piles and the
Good.
packages and stuff, just so we can include that in the PowerPoint. Just. But yeah, I took some. Yeah, so I think that will look good with the pictures and then with all the data and then some graphs and stuff like that.
I'm getting you more and more.
That's a good idea.
Yeah, so.
Are you ready to start?
Yeah. I'm ready.
Yeah, I definitely got it doesn't say king size on it. It says sharing size, but it's like 3 point. Let me see. I've still got the wrappers here. They're these 3.14 size.
Okay.
That's the size that I went with.
The one we were using. Oh yeah, that's like almost twice as much. So.
It is. Yeah, it says it's like 2 servings or sharing size, but it's still, even with that, there's still some colors that are only like 6. So it's just very unevenly distributed. So.
Wow.
Like I had a few where like the browns were like 5 or 6 in the whole thing. So, but I don't really know what else we can do. And each one of those packages is like $2, and so it's like I'm spending like $20. Yeah, I'm spending like $20 on these packages where I could get probably the same amount of M&Ms and like a couple of $3 to $5 packages, but that's all right. So
I don't know how else we could do it though, because we don't want to buy 10 of the really big packages.
Exactly. Yeah. So. I think it will be fine.
Okay, and then
Excuse
I was
me.
gonna say. Anyway. Okay, well, are we ready to start the
Yeah.
The torture.
quiz? Yeah.
I've got to go at 10, so we got.
Okay.
Okay, well, we'll try and hurry. Most of it, a lot of them were, we should be able to get through it in 45 minutes.
Yeah,
Okay.
it looks pretty simple.
It's just those first few that are,
Mhm.
well, there are a couple others towards the end, but anyway.
Okay.
Okay, deciding which hypothesis test to use. Here's a list of them, and we've studied so far in the semester. Questions 2 through 6. Identify one test that is most appropriate to the given situation. Some maybe use once, more than once, not at all, blah, blah, blah. Okay, in the article in the Journal of Small Business Management, are you recording?
Yes.
Successful startup businesses in the United States and Korea were compared. One set of data compared educational level, high school, undergraduate, master's, doctoral degree, of people who managed successful startup companies in the U.S. and Korea. You want to determine if education level differs between managers of successful startup company between the two countries. Which hypothesis test would be most appropriate?
Okay, so I guess we need to this is where I struggle. So like my first question is this categorical or quantitative?
Well, it's definitely. Oh, well, I would think it would be. So my initial thought, I hadn't thought of this before when I first came up with my answer, but with your question, I would think that it's quantitative because the successful business would be determined by their right?
By their numbers, that's what I'm thinking.
Right, which is all numbers. So I was thinking for this one, it's either between C or
Yeah.
D. Oh wait, is it C or D?
Yeah.
It's either the paired or independent or whatever. So I'm actually thinking it's D because they're comparing the difference between the ones in the United States and the ones in Korea, and just because one is successful in the United States doesn't mean that there's a connection or relation to the one that's successful in Korea. So I'm leaning towards D.
I'm sorry, just a second. My son's in here on me. So just a second.
Well, Gina, I was just thinking about that. Because you pick somebody from Korea, doesn't that make it so that you have to pick somebody from the United States?
No. See, I got one wrong. That was like, remember that, remember the question, this was a while back, but it had to do with the tensile strength of steel.
Yeah.
They were doing, they focused one company and their two different plants, and they were comparing, you know, the strength of their steel in each, that's coming out of each plant.
Yeah.
And that one, he said, was independent. I thought it was paired because if you pick one plant for, you know, your A samples, then you know your B samples have to come from their second plant.
Yeah.
But he said that there was no relation in terms of
I guess what steel you pick.
right, which steel you pick. So this is similar.
Yeah.
This is the same. Just
Yeah.
because you have one successful company in the U.S. doesn't mean that it's automatically going to be exactly which successful company in Korea is going to be paired with it. Does that make sense?
That's true. That's true. Yeah. I mean,
Okay.
you have to pick somebody from Korea and the United States, but there's 300 million people in the United States to choose from. So.
Okay, I'm sorry. My son was in here just bugging me to do something, and he wouldn't let up. So, anyways, what did I miss?
Well,
I think we settled on B.
independent
D.
sample t-test.
Okay. Yeah, I think I was stuck between paired and independent, so that would.
And one of the, so I'm trying to, as I'm going through this, I've been trying to pick out keywords that might help differentiate which test, to use over another. And I've noticed, and I can't see this is, I'll ask Professor Bennett today at the meeting, but I've noticed that when they're talking about differences, anytime there's the word difference, it always seems to be either a paired or an independent.
Okay.
So for me, in this question, it had to be either C or D, but because of the relation between a successful company in the U.S. to whichever one it might be in Korea, then I think it would be independent.
Okay.
Oh my. Okay, my son is on one today, so I'm gonna be back again. He's screaming about something. Hold on.
Okay. You also want to start reasoning through the next one?
Yeah, let's do that.
So a human resource manager reported data from a recent involuntary reduction in force and our customer. You are an attorney and must engage in a factor. It is illegal to the company reported the number of employees in 2 groups. So because it's a group, we know it's going to be either paired or independent, right? 40-year-olds or younger and 40-year-olds and older. They also reported a number of employees in each group terminated. We wanted to determine if both groups were treated equally, which hypothesis would you? Well, this to me is the same as, so I'm thinking it's D again. Because just because, Cindy got fired doesn't mean that, it's not going to tell you who the next person got fired was. It won't tell you any information, because they're just doing, the only groups are just by their age. There isn't any relation between the 2 of them, other than that they work in the same company, but that doesn't tell you enough about any relation.
Okay.
So I'm thinking D.
For 3?
Yeah, it has to be either C or D because there's 2 groups. And so A and B are out. ANOVA's out because that's like 3 or more.
Mm-hmm.
Tests of 2 proportions. That could technically be it, but they're not, I don't know. This is where I start getting a little confused. I mean, it could be either D or F, but I don't know.
So you're comparing the 2 groups and whether they were terminated?
It could be D or G, sorry. I don't know how to differentiate when to use an independent sample t-test over a test of 2 proportions.
Yeah, I don't either.
They are talking about they want to know if they were treated equally.
Right, which is that's not quantitative, that's categorical, isn't it?
Well, but that could be a comparison in proportions. So that's why I just don't know. Do you know what I mean? Like, so maybe we should come back to that. But it's either going to be D or G, that one.
Yeah.
Yeah.
The next one's also a proportion, so it's either F or G.
Or a survey is conducted, group of lottery, random sample of adults, total. You mean F or G? So this one's definitely going to be a proportion one. So it's either F or G.
Yeah.
Because it says we want to determine the portion.
Yeah. Yeah.
So maybe that's how we know that the one above it is not a proportion, and it's just
Mm-hmm.
an example. They didn't specifically say proportion. But I remember in some of our homework or quizzes just the last couple weeks when we were doing these proportion identification questions like this, they didn't all say proportion either.
Mm-hmm.
No, but the numbers we're talking about were you can tell were proportions. Like this one, it says total of 248, 152 were male. The one before this was just talking about 40-year-olds above and older.
Mm-hmm.
And if they were treated equally. I think number 3 was the not proportion one that we were talking about.
So wait a minute. So when we are doing, oh no, that wouldn't be. Well, but not necessarily. Like the one above, they could just be giving us the, because they give us the proportion. They give us the proportions. There's they don't give us the proportions. So that couldn't be a proportionate one.
Yeah.
Is that what you're saying?
Yeah.
Okay. They just tell us it's 2 groups. Okay, so then I'm more confident that 3 would have to be D.
Okay.
We don't have any information to calculate any kind of proportion.
Right.
So this one would be. So would it be a 1 or a 2 test?
I think it's just a 1 because it's just talking about the males in the group.
Males.
Yeah.
That would be F. Is that what you're saying, Phil?
Yeah.
I think that sounds right.
Okay.
Are we just supposed to put in lowercase letters?
Yes.
Yeah.
Okay.
Okay, so a student project compared the effectiveness of 2 different combination locks. One of the locks turned clockwise, the other counterclockwise. They asked 25 students to participate in the study. Each student was given the combination to each lock and asked to open the locks. The first time it took the open lock recorded to determine the locks. Okay, so this one is definitely a paired.
Paired. Yeah, that's what I got. C. Paired.
Test 1, test 2, or you could say kind of a before and an after. Do you know what I mean? But it's the same kid doing both locks.
Yeah, they're dependent on each other.
Yep. Okay, weight gain during pregnancy of the mother is an important indicator of health. A simple random sample of pregnant women on Egypt, Kenya, and Mexico was used to determine if weight gain during pregnancy differed in these countries. Which hypothesis test would be appropriate? See, that one says differ, so I would automatically think it'd be one of the T tests, either paired or independent, but there are 3 of them. So then
That's an ANOVA.
ANOVA, yeah. Well, it could be a chi-squared. Why do we chi-squared?
I had D, and let's see, what did I have for that?
The chi-squared one deals with
Independent or not?
Independence. Yeah.
yeah.
Okay,
So it's not that one.
so that's not it. So yeah, it has to be ANOVA because there's 3 of them. So it eliminates the 1 samples, the 2 samples, which leaves us with ANOVA.
Yeah, I think ANOVA would probably be right.
Because that's the only one that deals with 3 or more samples.
Well, besides the chi, but the chi-squared one. But I don't think that's the same.
No, because we're not doing dependence or interdependence necessarily.
Yeah, and they're trying to find the difference. Not. Yeah. Okay. Okay.
So differences then would be ANOVA, paired, or independent. and it just would, and then to decide which of those 3 to use, we just have to be able to identify how many samples there are, and then whether or not they're related. Okay, just thinking through, sorry guys. Okay, so that one would be E then, right? Yeah. Okay, deciding which confidence interval to use. Here's a list of them that we've learned so far. Might use them once, more than once, or not all. Okay, bank employee. A bank employs 2 appraisers. Okay, so we automatically know that it's either going to be a paired sample or an independent sample, because there's 2 of them, right? When approving borrowers for mortgages, it is imperative that the appraisers value the same types of property consistently. To make sure that this is the case, the bank evaluates 6 properties that both appraisers had recently viewed. Which confidence interval would be most appropriate? See, this is one where I would think that it would be paired because they're literally comparing, say, like they're doing the red house, the green, orange, yellow, whatever. So if one appraiser is doing the red house, we know that the other appraiser is also doing that red house. You know what I mean?
Yeah. Well, I thought it was paired, but I wasn't sure. This is one that I wasn't sure if it would be independent or paired, but yeah, that's kind of what I went with.
So I'm thinking C. What do you think, Phil?
E, yeah.
Okay.
Because we had a question almost exactly like this. Actually, I think it was this one.
Somewhere along the way?
Yeah, and I swear it was paired, but.
Because they can't be, I don't know why they keep putting that +4 confidence interval in there when we did not have that. But anyway, okay, in Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reported they were satisfied or very satisfied with their career path was reported. The same data was also reported for accounting majors. So we have 2 different groups. We have psychologists and accounting. We're doing a 95% confidence level interval. See if the observed difference is significant, which confidence interval. So it's going to be either the paired or independent again. Or it could be the confidence interval for 2 proportions, which we didn't learn, but I think the equivalent for that would be our confidence interval for 2 proportions. We just ignored +4 on the front of that. But we're not doing, since it didn't specifically say proportions, I'm thinking, and there isn't.
Yeah, I thought it was the independent sample T confidence interval.
Yeah, that's what I think too.
Good call.
I'm totally guessing though, guys. There's just no way to practice these because there's no place where there's answers and practice questions so that we can go through these. So it's just like a guessing game.
Yeah.
I hate these.
Oh, this one wasn't on our practice. O'Hare International Airport in Chicago has a reputation for having a large population at its flights being late. You design a study to see if this reputation is deserved. You find that the average on-time rate for international airports in the U.S. is 70%. You collect data and determine if the on-time rate for O'Hare, you decide to conduct a confidence interval. So we're comparing the average international airports to O'Hare. So there's 2 groups.
I mean, this is like a proportion, isn't it? Like one of the, because it's like a 70%. I don't know.
I think they're trying to throw us off with that proportion word because it says it has a reputation for having a large proportion of flights being late, but then it doesn't say anything about proportions in the rest of it.
Well, but it says that the proportion would be That's our null hypothesis would be 0.70. It'd be the 70%. So I guess I don't know. I'm leaning towards F.
So would that be a one sample z-test?
No, because there's two samples. Oh. Well, but we're comparing two samples, but we only have one. So yeah, actually, I think you're right, Phil.
What does he think it is?
It's either going to be E, one proportion, or it's going to be B, because we don't know the standard deviation. Oh, yeah, we do. That could be the average. No, that's the mean. That wouldn't be the standard deviation. So it's either B or E, right?
Well, because I have the categorical data analysis page pulled up, the Excel spreadsheet, and it says one sample z-test for proportion, and on the bottom it talks about one proportion, two proportion, the chi-square, and all that stuff. So that's what I was just going off of, the one proportion, and that would make it a one sample z-test. So I was just thinking about the confidence interval, I guess.
Well, okay, so here's another thing. The one that I got this wrong on one of the quizzes because I discounted the +4 confidence interval for one proportion because we didn't +4. So that +4 confidence interval for one proportion, I believe that's what that is this sample, that is the Z confidence interval for one portion. That's what it's supposed to signify. The one sample Z confidence interval that they have listed first is representative of the very first flow chart. Or you remember that flow chart that?
Yeah, I got the new one printed out, and I think you have to know the standard deviation for A.
That's why I don't think that one would work. We don't have the standard deviation. We just have the mean, which is 70%, but we don't have the standard deviation. So it's going to be B, which is the one sample confidence interval, because we know the mean, or it's going to be that interval for one portion. But I don't know how to determine, because it says proportion, I think I'll probably lean towards E.
Oh man, I hate this.
Oh, I do too. Well, I mean, and we got to think like some of these are for categorical and some are for quantitative, so that we have to figure out if what they're asking is for categorical information or quantitative information.
Where did you pull up the new flowchart?
It was on the individual preparation, like the link on that page.
Okay, hold on.
But it doesn't have everything filled in. It's just like it's like all the details on it are blank.
Oh, I see it. Hold on. I'm going to pull this up. I did not see that. Why is this not letting me download?
I don't really like that we have to take quizzes on something that we haven't. You know what I mean? It's like, yeah, well, we're just blindly taking. I mean, they have to have some kind of practice.
I know.
Homework stuff to prepare us for this.
Give us the information to begin with so that we can.
Yeah.
But they don't give us all of the factors to consider. Anyway, so I can't pull up that chart. But what does it? So which ones are categorical?
Well, categorical is like colors. It's any type of thing that's non-numerical.
So the only categorical one would be the chi, right? Then, because everything else is proportions.
Well, no. I mean, in this flow chart, the quantitative is the one sample, two sample, or three samples, which is the Z-test, the T-test, or the ANOVA, the paired and independent samples, and the ANOVA. Those are all quantitative. Categorical is like the 1 sample proportion, 2 sample proportion, and the chi-squared test. So I think that's the top dividing factors. In an earlier test, we had a lot of those questions where we were trying to figure out if they were quantitative or
I'd forgotten about all of that.
and categorical. Yeah.
I think and now I'm getting it. I guess one of the reasons why I'd forgotten about that is because even in the categorical test, you're dealing with numbers. So
Yeah.
I don't know how to.
You are, but sometimes it's just like, yeah, you're not, it's like out of its proportions, out of the categories is what you're dealing with, like a pie chart. You're dealing with proportions of the whole.
Right.
And so.
Well, okay, so for 9, I'm thinking, well, this is categorical. So how do we determine if this is categorical?
Well, let's see. I mean, it talks about a large proportion of its flights being late. You design a study to see if this reputation is deserved. You find that the average on-time rate for all international airports, which the average on-time would be, so that's kind of like the population.
So this would be categorical then.
I think
about either late or not.
Mm-hmm.
Or late. So then I would say it's E for sure.
That's kind of what I think. So.
That works for me. I have no idea on that one.
Yeah, I don't know either.
Double stuffed Oreos are supposed to have twice the filling. You and some friends decide you want to know if it's true by the company who makes them. You take a sample of 55 double stuffed Oreos and measure the amount of filling in each one. You need to construct a confidence interval to estimate the true mean filling amount in order to compare it to the filling amount in regular Oreos. So I originally put it's either D or E again on this one, but let's honestly think this through. So we're comparing the two, right? The double stuffed.
Yep.
And the regular. So it's either going to be paired, independent, or two proportion. Well,
we're doing amount, which is quantitative. It says you want to construct a confidence interval to estimate the true mean filling amount of double stuffed Oreos in order to compare it to the filling amount in regular Oreos, which confidence interval. So this is a quantitative study.
Paired or independent. This is where I would automatically think that this would be. This is like that steel one too, Phil. Yeah. I think it's going to be independent because just because you pick one cookie, it doesn't tell you exactly where you're going to get the other cookie.
The other cookie?
Yes.
That makes sense.
Even though we know it's going to be double stuffed and regular, it doesn't tell us exactly which double stuffed or regular we're using. So then that would be D, right?
I think so. There's a lot more of these questions that I think there was in the practice stuff.
Well, they added that O'Hare one. That wasn't in the practice one.
Jeez. Okay.
Okay, so I'm a little worried, though, because we have lots of D's on here.
Yeah. We'll go back. Let's go back to it. Let's go through the other things, and then we'll come back to those.
Okay, which one is the best? Which one best defines the notion of the significance? And that's that it's type 1 error.
Yeah.
And then the p-value is the extreme one, the probability of observing.
Or assuming the null hypothesis is true. That's right.
And then 13. Suppose you create a 95% confidence interval for the mean, and
this is 95% of all 95% confidence intervals actually contain the true mean.
see, I was, there are a bunch, I remember a bunch of questions like that. And it's it's either that one or it's the second one. And I'm not sure which one it is.
It's the 95% of all 95% confidence intervals contain the true mean.
So which one, when do you use the 95% of all sample means are between 1 and 10?
Between 10 and 20. I don't know that we use that.
Let me see if I can.
I have a lot of notes on this, and it's always that one.
Probably why I keep missing it.
Okay.
100 notes from a 10.
Let's see, which lesson would this have been in?
And I'm looking really quick. I just remember I'd gotten a couple wrong. I'd gotten ones wrong because I had picked the 95 of the 95, and it was and I don't remember what the details were. I can find it really quick.
I'm going to go back through my notes and see if I can find it, but I'm fairly positive. I usually get this one right, and that's the one that I would pick. Because the first one is we are 95% confident that the true mean is between 10 and 20, which is in the question. And that's the first one. And then the second one is 95% of all 95%. That's how they always word it.
It was in one of the, I want to say,
I think it's in lesson 17.
okay. Okay, okay, so there's one in our homework, and it's saying that it would be that we are 90%, or that we are 90% confident.
Which is in the answer, and then the other one is the 95% of all 95. Let's see.
It's this one. So in our homework, question 17, question 8, it says, what does the phrase 95% confidence mean? Isn't that what they're asking here? Confidence. So this is saying that if we create 95% confident intervals, 95% of them will contain true proportion. So yeah, it's got to be that one. I must have. I need to go back and just figure out why I was confusing that, but I know it's never a chance thing, and it's not a data thing, 90%,
Well, the other one, your stuck one, says 95% of the sample means are between 10 and 20. We're trying to do the confidence interval, not the sample mean. So it's saying, and the true way to say that is the true mean.
not
95% of all 95% confidence intervals actually contain the true mean. So it's
That's
never going to be a chance. It's never going to be, 95% of the data is between 10 and 20. It's going to always be that it's, we're 95% confident that the true mean is between 10 and 20, or that the confidence interval actually contains the true mean. So
that's where I messed it up. On this one, too, it gave it away because it says it wants the true mean.
yes.
And the true mean and the sample mean are not the same.
Yeah.
And
JD.
anyway,
Okay.
all right, thanks for looking that.
No problem.
Yeah, okay, you take a simple random sample of 100 adults from a town in the U.S. to determine the proportion of those in town who invest in the stock market. Assume the unknown population proportion of percentage of people in the town is 0.30. What is the mean of sample portion? So for this one, I did our P is the mean of the sample proportions, right?
Right. So 0.30, isn't it?
Yeah.
Mhm. Yeah. That's what I got. So, did you get that too, Phil?
Yeah.
Okay.
And then the second one, the standard deviation, and we just had to work out the
These.
pi-hat
Mhm.
square root of P times 1 minus P over N, right?
Yeah, and I got 0.046.
Yeah, that's what I got.
Sorry, guys. Hang on a sec. Yeah, love.
What?
What's up?
Okay, what's the probability that your random sample of 100
Okay.
will have
Hang
this
on a sec, guys.
proportion of less
That's
than
fine.
5?
It took me a few times to work this out, but I finally came up with, I think, what is the right answer. But I've got P.138, which is A.
Well, so for this one,
You have to use the normal probability app and do the whole shebang, or you have to enter it into the.
that's what I couldn't remember how to do it, so I didn't do it. So how did you do this one? I couldn't remember. If we have to
Yeah,
go
I kept confusing it. I finally went back to a former problem that was very similar and then worked that out again so I could know how to do it. But yeah, you take 0.25 minus 0.30 divided by the square root of 0.30 times 1 minus 0.30 divided by 100.
Okay, hold on.
And
So hold on. For the problem, it would be 0.25 minus
0.30
divided by what?
square root of 0.30 times the parentheses 1 minus 0.30 divided by 100.
Sorry, I'm writing this down and I wrote it wrong.
It's okay.
0.25 minus 0.30 times square root of what?
It's 0.25 minus 0.30 divided by.
Why would it be divided by?
Because it's the problem is P hat minus P, and then divided by P, the square root of P times 1 minus P divided by the number, the sample number.
So we're trying to find the z-score?
Yeah, we have to find the z-score, and then we have to go to the normal probability app and enter that into there and find, yeah. So, I mean, this is like the long way. I don't know if that one sample proportion test does all this for us. I couldn't exactly figure it out, so I couldn't
figure it out either because I punched in the numbers and it wasn't coming close to anything like that.
Right.
Okay, so you did.
I think I finally got it to work though, but I had to use the quantitative inference procedure, I think. Or what did I have to use? No, I used the categorical, but I'm not sure I think I finally got it to work, but I'm not sure how I did it.
Because
I
I
don't
was
know.
trying to use the categorical
Yeah.
instead of putting, so the null hypothesis would be 0.25, right?
Yeah, let's see. Let me go to one proportion, but
Oh,
yeah, let's see the
was 100 adults, and there were 50 of them, right?
50 out of 100. Let me see. I don't remember. I think it's point.
It doesn't tell us how many.
Yeah, it doesn't. It just says it's 0.30 as the percentage. So
Oh, then do we just put,
0.30.
see if that works? See, but then I'm getting, oh, we want less than, right?
Uh-huh. Yeah, I'm.
But I get like nothing, zeros.
Yeah, that's what I got too. So I did it by hand, and it came out right. So I don't know if this is the wrong. I think this might be the wrong. Like we didn't in this because this was from chapter 16, and I don't think we were using this Excel thing yet for that chapter. I think we were doing everything by hand. So I just went back and did it by hand, I think, on this particular problem. But I did the 0.25 minus 0.30, which is negative 0.05.
Okay, hold
And
on.
then, okay.
I'm gonna try and work it out. Just to make sure I'm doing my math right.
Yeah. And I just like set it up in Excel too, so it would do it for me pretty quick.
What are we on?
We're still working on, what question is it in the quiz? It's the question 16.
What did we get for 14 and 15?
Oh, 14 we got 0.30, and 15 we got 0.046.
Okay.
Okay.
Wait. I thought we were on 13.
Well, in the textbook it is 13, but on the quiz it's question 16.
That's right, because they added another.
Mm-hmm. They've added in, yeah.
1 minus 0.30.
Did you get this one already, Phil? Like, have you worked this one out?
I haven't.
Okay. I did this one by hand, and I did 0.25 minus 0.30 divided by square root of 0.30 times 1 minus 0.30 divided by 100. And that's how I found the z-score, and then I put the z-score in the applet, and that's how I got the...
So for your z-score, did you get a negative 1.09?
Yeah, exactly. Negative 1.09, I think 2 or something like that, or...
Yeah, 1.
Yeah.
0.
Yeah. Uh-huh.
And then we go, hold on, I'm doing this as we speak. So we go to the applet.
Mm-hmm.
So long since I've done this, it makes me nervous. So we put in our z-score, 0, 9, 1. And then we want to select the area since we're doing less than. We just do the left side. So then I get 1.138. Is that what you got?
And that's exactly what I got, yeah.
Okay. All right. Well, we're either we both really don't understand how to do this,
Uh-huh.
happen to get the wrong answer twice, or...
Wait, I'm so confused. I'm sorry. I just blanked out for a second. 138.138?
0.138 is what I think 16 is, yeah.
Okay.
I mean, and there was like some questions in like homework and like earlier chapters that were very similar, and I made sure that those were the right questions and reworked it out. So I know I'm pretty sure we're doing it the right way.
Yeah, I think so too. Okay, 17. Use the following information. Clinical trials. In clinical trials of Acupril, 2,142 subjects were divided into two groups. 1,563 subjects in the experimental group received the Acupril. 579 received the placebo. Of the 1,563 in the experimental group, 61 were experienced dizziness. Of the 579 in the control group, 15 experienced dizziness. So on this one, I used the 2-sample Z test. Is that what you guys used?
I think so, yeah.
Um,
Well, yeah, P1 minus P2.
for proportion. So then I just put in the 61, 61 for X1, and then N1 was 1,563, X2 was 15, and N2 was 579. And then I kept the confidence level at 95, and then I did not equal to. Is that what you guys did? So then my confidence interval I had was negative 0.003 and a positive 0.029.
Yeah, that's what I have, and they changed the answer on this one to 0.004 and 0.029, so I don't know why it's a little different, because it was right on the textbook.
What type of test did you guys use for this?
The 2-sample Z test for proportion.
Oh, they took out one of them.
Yeah.
They took out the, so does that round up? What is the?
I don't know. I'm going to have to enter it all again because I'm not sure why my answer's not here, but it was in the textbook. Okay, what was it? Let's see. The 579.
They only have 4 options now, and in the practice they had 5, which included ours.
Oh, okay. What in the world?
Oh, that's a little unnerving.
Okay, so let's see. The 1,563 subjects in the experimental group received Acupril, and 579 subjects in the control group received a placebo. Of the 1,563, 61 experienced dizziness, so 61 out of 1,563.
Are we doing the wrong test? Should it be something other than the?
I don't think so. This is definitely the right one. And then it says for the out of the 579, 15 experienced dizziness, so 15 out of 579. Oh, this is definitely the right test. And then it's a 95 confidence interval.
That's
and the type of test is not equal, right? Let's see.
Yeah, because they don't give us any other information. They just are comparing the two.
And I get a 0.003.
Yeah, it's not on there. So let's keep that one, and
we could do that by hand. I just don't.
Well, that's the right answer. I think because it's definitely not. I guess I suppose it could be the C.
Well, that's what I'm thinking. Like they rounded it up for some reason because 0.029 is correct. 0.029 is the correct one for the high point, but we have 0.003 and they have 0.004.
So remember how sometimes he was saying that if it's within like a certain percentage, so let's put C, but maybe hold off on that. Come back to it.
Let me see. But did they? Yeah, they have it in. It was E in the textbook. Yeah. It was in the textbook, but it's not in the
test.
The test. That's
what we could do. Since this isn't one that we have to submit after we start it, we can save it for later. But at the meeting today, I can ask them about that too.
Oh, before we submit it for
yeah.
That's probably a good idea. Okay.
So 18, perform a test to see if the proportion of experimental group subjects which one would you choose, basically? Well, since we know it's a proportion test, it's going to be P1, the null is equal to P1.
Mm-hmm.
And then since we're doing, they didn't tell us whether they're trying to see if it's more or less, then it has to be not equal to. So it's
B.
right? Yeah.
Yeah, I have B. P1 equals P2. HA is P1 is not equal to P2.
Test statistic, I got the last one.
D, the 1.458.
Yep.
Mm-hmm.
The p-value, I got the last one also.
Me too.
Likewise.
Is there significant evidence to conclude that the proportion of people is different than the true proportion of people who experience dizziness? And I thought that it was no, because we failed to reject. No.
I said no. I failed to reject HO. So E.
Yeah.
Yeah. And then
19.
No.
Oh.
I'll just call you. Okay, a survey was conducted. 1,279 randomly selected adults under age 18 and older were asked, are you a morning person or a night person? The hypothesis for the study are morning or night. So this is categorical.
Mm-hmm.
Isn't this the
And
chi-square?
it's the chi-squared, yeah.
Yeah. Calculate the test statistic for the hypothesis, assume the requirement. So,
So I entered all this into the program, and I still have it up, I think. So let me.
I did
I do
too.
too. I just barely did it.
Okay, chi-square. Okay, so it's asking for the test statistic, and I get the 8.6. Let's see. Oh no. wait.
6
Should be 6.580.
Yeah, that's what I got yesterday. Maybe I don't have the same one up. Hold on, what's going on? Yeah, I have different numbers in here. That's why I'm like, why is this not up? Okay. Contents.
So I got the same thing Phil got.
Yeah, I did too. I just, I guess I did another problem afterwards that is got different numbers in here. Okay.
So the test statistic was
6.58, and that's A.
what problem are we on again?
That was 22.
I missed.
Now we're going to 23.
Okay.
This is calculate the p-value for this hypothesis test. Assume the requirements are satisfied. So I get 0.0866, which is D.
Well, no, I got 0.087.
Well, yeah, when you round up, that's what it does.
You round up.
Okay. Should we reject it or not?
It is still larger than a 0.05 significant level, so you would fail to reject.
So the second to last one, right?
It says, yeah, no, the p-value is greater than 0.05.
Yeah.
So it's E.
25.
Do you have sufficient evidence to conclude that age makes a difference? I put,
Last one.
yeah, F. No, I failed to reject HO.
Okay. Now this is one that I had a question on. 26. So I was doing it by hand, but which test could we use to double check it?
Let's see. Which one did I use?
I wasn't sure. So we're talking about proportion. And and I guess it'd be the 1 proportion then, right?
Yeah.
So then we would just put in a recent book noted that 20% of all investment managers, so that would be the null, right? 0.20. And then the random sample of 200, and then 50 of them, or the number would be 200, and the X would be 50, right?
Mm-hmm.
So, but what I'm getting, oh, are we doing less than?
It's greater than, I think. Let me reread this. I haven't done this since last night, so. So this is so the null hypothesis is 20.20.
Right, I got that.
Random sample of 200 investment managers, so the N is 200.
The X would be 50, right?
Yeah.
About the 50 that outperformed the.
Yes.
So then the type of test, I just put not equal to, but they say if it's going to be less or greater than. It's just.
This is.
They just want.
Well, it says outperformed. It says let P be the true proportion of investment managers who graduated from one of the top business programs who outperformed the null hypothesis. So they did greater.
Well,
did better.
I don't know that. Are they saying that they outperformed the null, or are they just saying that because they're only counting the people who outperformed? Who do you know what I mean? Like that was the definition of their sample group.
Okay.
Not that they necessarily outperformed the average. It's just that in order for them to have been counted as the sample, the sample group, they had to have outperformed, right? Well, either way, so that wouldn't change the confidence interval, but I'm not getting, my confidence interval is not an option on there.
Neither is mine.
I get 0.190 and 0.310.
Yeah, the confidence interval I got for this one was 0.190 and 0.310. So
yeah, we all got the same, but it's not an option.
Right. So I went working it out by hand, and I was doing the remember the p hat?
Yeah.
P hat equals the square root of p minus 1 minus p over n. And so then I get 0.306 as our p hat, but then we still have to find the interval, which I hadn't finished working out yet. Because we have to do the plus or minus thing, right?
So this one that there wasn't a multiple choice on the textbook for. Is that why we're not getting what was in there?
Yeah. Well, no.
Let me see.
So let me see if I got. Actually, the option I got in our textbook, I got C, but it's not in this one. It's another one of those. They took it out.
Oh, yeah, it is in the textbook, but it's not an option on the quiz.
I'm a little nervous because does that mean it's not right? And so they took it out. Do you know what I mean?
Yeah.
But
it was C in the textbook.
Right. So I'm working out really quick to see if we get a different.
Maybe this is one that has to be done by hand.
I'll ask him. I don't want to necessarily spend the time right now. Let's not submit our assignment until after the meeting today, because I'll ask him.
That's a good idea.
Okay. The next one is suppose you'd been in charge of designing the study. What sample size would be needed to construct the margin of error 2% with a 95% confidence. So this one you had to work out. And I got a huge number that's not even on there.
I got, let's see.
I got 1,250, which isn't one of the options.
Yeah, I got 1,537.
Okay, so how did you get that? I need to see where I messed up on my calculations.
Sure. Okay, so this is the prior estimate one. So the formula for that, let me pull the formula up. Okay, for the prior estimate. Okay, so the formula is you do the Z, which is like 1.96 for a 95% confidence interval, and you divide that by the
Margin of error.
the margin of error, 0.02, and then you square both of those, so it's up to the second power, and then you multiply that by the prior estimate, which is 0.2, and then you multiply that by parentheses 1 minus prior estimate, so that's 1 minus 0.2. And so when I put it into the Excel sheet, it comes up to 1536.64, and then you always round up. So that would be 1537.
Okay, I must have just messed up in my calculations because I have the right formula,
Mm-hmm.
but I'm just getting a slightly different. So you did 1.96 divided by
0.02 squared.
0.02. So I did
Because the margin of error is 2%, so you 0.02, you can't multiply or divide by.
Oh,
Yeah.
so I
just changed it to a decimal form.
So do you know what I did? Is I put, you know how we have a formula to find the margin of error? So I just found the margin of error, but I obviously did something wrong there. So then you did 0.02, and then you
square that thing, yeah, and then you're going to multiply that by the prior estimate, 0.2 times 1 minus 0.2.
So did you get
I got 2401.
9,604 times 0.1613? Okay, now I got the right answer. Okay.
You got 1537.
Yeah. Well, 1536.64.
Yeah.
Rounds to.
Yeah. You're getting the wrong one.
Hang on.
Yeah.
So we're trying to find N, right? The sample size.
Right.
Yes.
Right.
So
But this is with the prior estimate.
So the formula for to solve for N with a prior estimate is Z
divided by
margin of error, or M, squared times P times 1 minus P.
Oh, okay.
Mm-hmm. And P is the prior estimate, yeah. So it's like P with the little asterisk above it. So.
Okay.
Meaning that you have to use yeah.
Well, in 27 it has the P asterisk with 0.2. It gives it to you.
Right.
Yeah.
Okay. So wait, what did you just say? That P asterisk means what?
That's the prior estimate. That's the symbol for prior estimate. Yeah.
I missed that. Okay. So when would you use? So I was trying to solve. I solved by hand first for margin of error.
Mm-hmm.
And I got something totally wrong. So how did you get? When would we use that? When would we use the formula to solve for the margin of error first? When we don't have the margin of error given to us. I didn't think of.
I don't know if I had that one for this. I mean, we had it for our last. We had the formulas for the last exam. Let me see. I don't know that I have margin of error.
Because
Oh,
I
well,
use,
if you don't have a prior, if for the margin of error number with no prior, yeah, because you're solving for the margin of error, not on both of these, not.
So we would only use that without the prior. Okay.
Yeah.
yeah, because I was gonna say because I used the one that's like z divided by 2m squared, and I got the 2401.
Yeah,
So
I think that's the margin of error without a prior estimate.
Yes,
So,
but we have the prior estimate, so.
yeah.
Yeah.
Okay, so 28, it says, use the following informations for 28 through 32. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. Which of the following pairs of hypothesis is most appropriate for this question? So
I got 2 because it's not, they don't give us a greater than or less than. They're just saying that there's a difference.
yeah, I think I've got, well, they say performs better than the investment managers.
Oh, so that would be
It's greater?
greater than.
Yeah. So I've got P equals 0.2 and HA is P is greater than 0.2.
Yeah.
This is the third one.
Yeah.
Third one, right?
Mm-hmm.
How many measurements must you have in order to assure that p hat is normally distributed? That's 10.
Yeah, that's the NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10.
Yeah, because the 30 is for the central limit theorem. And the only time we use a 5 is when we're doing confidence intervals. So
Mm-hmm.
when we're talking about
Right.
10 or just the hypothesis test in general, it's always
Mm-hmm.
the 10. And there's never a NP is greater than 5 or N, the one that's like just totally made up.
Yeah.
Okay, next one. The value of your test statistic is, so now this was the other thing. So do we need to punch this into?
Yeah.
So we're using the, this was the one where I got 1.768.
I did too.
Okay.
Likewise.
Likewise? Okay.
And then the p-value is 0.007, the last one.
I got 0.039.
Likewise.
How'd you guys get 0.39?
Did you have the wrong?
I did not equal to.
Yeah.
This is greater than, right? Yeah.
Mm-hmm.
Good catch, because I got that wrong.
Last question. Yay.
Oh, yay. Oh, they cut off a whole bunch then. Let's see.
Well, no, they just didn't give us. We have to pull up all the information, right? Oh, they did cut off.
Yeah, because I had like 10 more questions or something, like 38 altogether in the textbook. Okay.
Is there significant evidence to conclude that the graduates in the business, so the p-value is less than, so we reject.
Yes, I rejected
HO.
HO, which is A. Yeah, you know what? All the rest of the questions seem to be from like former units. Like I had to go back to the quantitative, descriptive spreadsheet, the quantitative inference procedure spreadsheet, and do that. Yeah, it was for like the former quizzes and stuff, but they didn't even have like multiple choice, so I don't know if I did it right or not.
Well, I hadn't worked any of those out yet.
Mm-hmm.
But so before we save our tests and don't submit them until I can talk to.
Yeah, I'll see if I can go. I babysit like right in the middle of his meeting, but we'll see.
But then I was also going to say, do you guys want to meet Thursday for any, I don't know, to go over? At the very least, we could go over what we if we never get the answer sheet for the that thing that you just forwarded us.
Well, unfortunately, I think that the quiz is due by like early Thursday morning. It's like midnight, almost like an hour after midnight on Wednesday. So.
Oh my gosh, I have so much to do before then. Oh.
I know. So I don't. So Thursday would be kind of obsolete. It'd be after the fact. So.
It is seriously due Thursday.
Well, it's like at 12:55 a.m. Thursday morning. So it's like basically Wednesday night. Yeah.
Oh my gosh, that just added a whole heap of stress. Okay.
I know.
Totally thinking I had.
But then after that, we don't really have anything. I mean, we could get together to meet about our project, or we could just, take a break or whatever you guys want to do. So.
Well, you said you're gonna try and go to that meeting today too.
I'm gonna try. Yeah. I just have a lot of questions, especially about the being able to tell between the tests, and so like I'm really not confident with any of our first 10 answers or anything because of the I just really can't tell the difference. So
I'm trying to like I think that I'm understanding, so I'm able to narrow it down to like I know it's one of two things.
Yeah.
I don't know. I have a problem doing that too. It's hard.
Mhm. Yeah.
Well,
but I think the rest of our answers are. I feel like we're pretty confident with them. There was that one that we weren't.
Well, there's just the two that the answers are not on the answers.
Yes.
They're not available anymore.
Which ones were there? I'm gonna make a note so that I can ask him.
14. Well, so I think it's 14 on our paper, and the homework I think it was like 17.
17, is that right? Yes, it was 17, and what was the other one?
Ours, so I think it was 25 or 6 or something.
Yeah.
Which one was it?
26.
Okay.
Answers not on quiz.
There were some that were close, just not.
And we want to ask about that. There were several. I'll ask them about this too because like on the test or on the last quiz, I got it wrong, but it was supposed to be right. But the one that talked about that +4 over whatever, even though we don't have +4, we didn't learn +4.
Mhm.
It's just the 2 proportion one. Where is that? Do you know what I'm talking about?
I don't know. The +4 confidence interval thing, or?
Yeah, where we don't have a +4 confidence interval. The only thing that we've said it because they've taken it out of the curriculum.
Yeah.
They didn't change it. It's supposed to be just confidence interval for one proportion or.
Yeah, and that was the right question on one of them. Yeah, I know.
And so I wanted to ask them about that because I got it wrong on the last quiz because I was like, well, we didn't know because they took that out. So, but then it was anyway.
Yes. Yeah.
Okay.
I don't know this. Yeah.
No, this exam has to be tomorrow.
I know. I really need a good score on this too.
Me too.
Yeah,
Too.
I'll be failing in class otherwise.
I have asked if we could do extra credit, and he's like, no. I'm like, come on.
No kidding. Why?
Give us some extra credit because this, like, we're all trying here, but there's not, you know.
Like I said, I think what's most frustrating is that, particularly in determining which hypothesis test to use, it keeps throwing in different factors that we have not
Studied. Yeah.
studied. And so it's almost like the only way you would know this is if either you had exposure to it
Yes.
and an example prior where
Mhm.
you were able to, you know, differentiate, you know, whatever they were talking about
Right.
to what you know,
Mhm.
or they had literally spelled it out for you in our reading, and they don't spell it out to you.
No,
And
they
so
don't.
no way.
There's no, like, it's not in the textbook. There's no, like, this is how you differentiate between the different hypothesis and confidence. It's not in the textbook. It's not in the homework, like on the individual preparation or assignments or the homework assignments. It's just been on the quizzes. That's it. And it's just like, yeah, I've sent him an email though and said, yeah, that's not very fair. So
It's frustrating. All right,
so-
well, I'll reply to our, hopefully we'll get a couple more points for design the study submission.
Yes.
Had
Yeah.
everything in there. It's just maybe not listed so it's easy for him to pick it out, but it's still under each question. Do you know what I mean?
Mhm.
So maybe hopefully we'll get a couple more points on that.
Yeah, I hope so. Okay, well, I'm gonna just save it for later, and then.
Yeah, I
You
did.
guys, I won't be able to go. Do you guys just want to send an email, or do you want to meet up later or something?
Yeah, we can do that. Yeah, we'll send a text or an email.
Okay, thanks, guys.
Yeah, you're
Okay.
welcome. Good luck on the test.
Yeah, good luck. Bye-bye.
Bye.
All right, we'll see you in a couple hours then.
Yeah, sounds good. Yeah, we'll be there to be like, hey,
Your half points.
can you give us some half points on some of these? Yeah, for reals.
Uh,
So frustrating. Okay, all right, we'll see you later then. Okay, bye-bye.